Well, good evening, ladies and gentlemen. My name is George Young. I'm connected with the Center for Global Humanities as a research fellow, filling in tonight for our director, Anouar Majid, who is somewhere up in the clouds. He flew in from Morocco just yesterday, and now he's heading down to New York, and we may be hearing from him, or we may not. I don't know. So we'll go ahead and get started. And if he can Skype in, or find some other way to come in from the clouds, he certainly will. But it's a pleasure tonight to welcome you to the first occasion in our program for the semester. The talk by Jacqueline Vanacek, Will Cloud Computing Really Be Bigger Than the Internet? Now, perhaps like me, many of you remember the very early days of the Internet. What a mystery and a thrill it was to sit there beside your computer listening to these various tones from the telephone connection that we had, and the buzz up, the buzz down, and so forth, and then finally some kind of recognition that we were connected. And you wondered, am I really connected to all of this going on out there? And then the thrill to find that really you were connected to the whole World Wide Web. And it was just an amazing experience suddenly to be sitting wherever you were. I was in North Berwick, Maine, sitting there being able to go online and get connected to the library in Oxford, England, or so many different places, have access to information from around the world. And now it's possible that something even more wonderful, dazzling, important is coming along. So we really look forward to hearing from it about this. And we couldn't be hearing about it from a more knowledgeable, a better person. Jacqueline Vanacek has been vice president and cloud computing evangelist with SAP, the largest enterprise software provider in the world. She's also a U.S. commissioner on the federal and state local cloud commissions to transform government. She blogs regularly on Forbes and contributes to the U.S. high-tech lobby policy blog. Jacqueline shared her Sandhill Group studies findings with U.S. Departments of State and Commerce on how cloud impacts job creation and economic growth. She also engages with the European Union and is educating several Asian nations on their cloud opportunity. So please join me in welcoming Jacqueline Vanacek tonight to speak to us about the cloud.
Thank you very much for that very warm welcome to UNE at Portland. And how this all came about was that I work in the software industry, and I'm located in Palo Alto, California. And I was at the Social Innovation Summit at the United Nations in May and met Anouar. And we got to talking about the cloud and how transformative it is and will continue to be for a very long time. And that's how he had asked me to come and speak to you here. I'm originally from the East Coast. I went to college in Vermont. I have family who live in Vermont, and my sister and her husband both went to school in Portland. My brother-in-law went to school here. And so all these interesting connections that were a total surprise when I met Anouar. So it is really a pleasure to be back in Portland. I've been here a couple times before, a long time ago, but it's just a lovely place. And I've been having a wonderful time since I've been here. And I'm delighted to have the opportunity. And regarding my background, SAP is the largest enterprise software company in the world. We sell business software for transactions for very large companies, medium-sized companies, and a few small companies. We supply the software for all the multinationals, Ford, Motorola, Procter & Gamble, We have our own set of cloud solutions. And my job is partly to promote adoption of the technology with governments and customers, commercial customers around the world, and to identify what their opportunity looks like. And I represent SAP on some outside bodies as well. I work with countries all over the world. The opportunity for cloud computing is really staggering, and I'm really pleased to have the opportunity to tell you a little bit more about it. So, cloud computing will have a greater impact and will create more jobs than the early internet did, because the confluence of cloud with mobile, social media applications, and big data will reinvent the entire IT landscape. That was the finding of the Sandhill Group, who had done a study on the impact of cloud computing on job creation for the United States. And this was the study referenced in my introduction regarding how big cloud computing will do. And I shared the information with the US Departments of State and Commerce, and some of that information was shared with the European Union. This is a very big opportunity for many countries around the world. And the reason is that the IT infrastructure will be reinvented for the next 20 to 25 years. This will become the new way that we manage IT systems. The mobile cloud paradigm is the biggest, and we call the mobile devices the cloud in your pocket. So your data will be in the cloud, and you'll be able to access from your mobile devices or your desktop, whatever computer you have. But the future lies in the ability to access from some interesting variety of mobile devices. All software in future will be developed in the cloud, will be developed and delivered by the cloud. And a lot of that is happening today. Most of the growth in the IT industry around the world will be because of cloud. The mobile applications will fuel continuous innovation. So you'll have access to all sorts of new and interesting things. I just read a study this morning from an economist that identified that there are 725,000 jobs in the United States associated with what's called the applications economy. So the innovation to come in future is all about the applications, the things that you run on your smartphone, what you run on your laptop, your iPad, whatever. That's where the innovation is going to come from, the applications. The ability to develop that and deliver that in a really fast and unique and cost-efficient way is what the cloud does. One of the questions I get asked a lot, several questions, is where is the cloud? Anybody have any ideas? I put up some of the things that people think about where is the cloud. And I'm sure our listeners who are online participating are wondering about this too and have their own ideas on where is the cloud and who invented it. I was in China a couple of months ago, meeting with the Ministry of Science, talking to them about the cloud and best practices. And one of their questions also was, who invented the cloud and where did it come from? When I met Anouar, he was anxious to talk about Dropbox because he uses that. A lot of people think it's Amazon. LinkedIn, by the way, just within the last few weeks, was written up as now having the greater market capitalization as a cloud solution over Salesforce. That's a really big deal because these are the big cloud applications that are evolving and growing in use by everybody. So these are a lot of the cloud applications we're familiar with. Facebook, Twitter, Gmail was an early one. The iCloud, everybody's familiar with the Apple iCloud. Amazon, not only does Amazon sell retail products, but they took their excess IT capacity for their retail products and they started selling it. And they developed an entire cloud service. They are a juggernaut with 80% of the cloud market share all over the world. They are huge. So, where is the cloud and who invented it? Well, that was a trick question, folks, because the cloud isn't a place, it's a compute model. Cloud computing is a compute model, and it is the abstract collective of all of the data centers that run a cloud computing model that constitute the cloud, okay? The US National Institute of Standards, several years ago, embarked on a mission to define the cloud. Timothy Grants and Peter Mell. And those names are well known in the cloud community around the world. And they chose to define the cloud not for the rest of the world, but for themselves, because they were hearing about so many different models and services, and they tried to put it all together in a framework that made sense for them, and they are the organization that's responsible for defining standards, technical standards, for all the US federal agencies. And they ultimately defined a version of cloud computing or a framework for it that is now embraced all over the world. And what the cloud really is, the cloud compute model, is that you have the ability, both consumers, businesses, developers, you have the ability to access software online over the internet, typically, with pools of IT resources in the background in a data center. You don't know where it is. You don't care where it is. And the time you spend on the infrastructure using the application is basically rented. So you're accessing an application that the application provider is only paying for as much as the application provider uses. And that means that you're bringing computers and storage devices and network capacity together in an on-demand way, on request, based on the number of users, delivering service so that you can get on Facebook, you can read your newspaper online, you can surf, vacation, or book airline, whatever you want to do, run your business, do your financials, that you can do that and do it in a way that the IT people can access infrastructure that they no longer own, they no longer wholly see or control, but they pay a lot less money for. And it all happens on demand. A little bit of this, a little bit of that. Let's put it together. I need this for 6 months. I will pay this amount of money. After 6 months, I'm done. Boom, the resources go back to the cloud. And someone else can use them. And that's what cloud computing is. It's a compute model that allows for the on-demand assembly of computer infrastructure to run the applications. Think about if all of the 1 billion users of Facebook all got on at the same time. 1 billion users around the world getting on Facebook all at the same time and uploading a video. Think about what that takes in the background in IT. It takes a huge amount of IT horsepower, compute power, storage, networking to allow that many people to do it in record time so that you, the consumer, are satisfied with the performance. You don't want to be sitting waiting. You want it done now. You want it done yesterday. You're used to that. But the scale of supporting 1 billion people, 1,000 adults, and the rest teenagers all over the world, right? Doing that at the same time. The cloud came out of based on early concepts from the mainframe industry and has been built in the internet industry largely because they deal with a scale of users that far exceeds anything that had ever been dealt with before. And so when you think about email, how many email, think about how big Yahoo email is. It's the largest email network in the world. And what kind of infrastructure do they need to support all of their users? And how do they do it without buying more and more and more and more boxes and fulfilling more and more and more data center space and paying for more and more and more electricity and being able to support that and not charge you a fortune in your access to email? You don't get charged anything. It's paid for by advertising. So that's the power of the cloud, and that's why this as a more alternative way of bundling IT infrastructure and then delivering software or development tools for the people who write code, that's why the cloud evolved. And this is so big in terms of how it's going to reinvent infrastructure that it's changing everything. So what I want to talk to you about a little further is now, what is the impact of the cloud? How is it changing government? How is it changing how we as citizens can interact with government? How is it changing business? The cloud affects every business from startup to multinational. There are some incredible stories regarding how it will change data, big data, and research. And education, something I'm sure everyone here and our online listeners have a special interest in, is how is the cloud affecting education? I was active on the U.S. Cloud Commission for the federal government, and I was one of the people who ran the state local cloud commission for the U.S. And I was involved in a European consortium. It was very interesting. I was the only American involved in an industry and nonprofit agency consortium for a cloud computing proposal for the European Union. And I work with several governments in Asia, China, and Kazakhstan, most notably right now, about how cloud computing can modernize their government. And cloud computing, the impact of cloud computing on government is allowing government at the federal level, at the state and local level, all over the world, to actually improve government service delivery to the citizens and also engage with the citizens in a way that wasn't possible before. And that's what's so fascinating about cloud computing, is the real benefit isn't that the IT people and the CIO save money on delivering infrastructure. They usually pay 60 to 80% of the whole IT budget is just to run the infrastructure. It's like paying a mortgage for your house. You know, you have to pay it. It's the same amount every month. You don't get any more, you don't get any less. You have to pay the same thing regardless. Well, IT infrastructure is a fixed cost like that too. And it eats into the way that you could potentially be delivering new applications to help the business people. So the impact of cloud on government is really changing everything. And there are some incredible thought leaders in the United States that are doing things with cloud computing that are setting a benchmark for other governments around the world. And part of what I do is take those best practices and share them and build collaboration between groups so that everybody benefits. So there's something called a cloud first policy, and you may have heard that in the US federal government. The cloud first policy was adopted several years ago for the US government by the federal CIO as a way of saying, if we have to buy or do something with IT infrastructure, that we find a cloud computing, we look for a cloud computing solution first. And if we can find it first, that's better than buying something outright or building our own. The US federal government is the largest IT customer and consumer in the world and spends $80 billion a year on IT, only IT. So any opportunity to save 30% of that, which could be the result of migrating to the cloud, has massive implications for the government. And that's one of the things that's so fun to talk about cloud, is that everything is always on such a huge scale. You know, I mean, the numbers can be really big. So the US adopted a cloud first policy and required that all the agencies a few years ago start within a certain timeline, move at least 3 services to the cloud. At the state local level, there is a lot of adoption of a cloud first policy as well in the United States. New Zealand has a cloud-first policy. Macedonia has a cloud-first policy. I spoke with somebody, a policymaker from Macedonia, when I was at a policy conference at Stanford recently with Madeleine Albright. And so this is being adopted everywhere. And I want to talk about the state of Michigan and the state of Illinois, because they have some real thought-leading models that are just incredible. And these people are doing incredible things with innovation with almost no money and almost no people, and they're getting it done in a way that's unique and really unusual because they have to. They have no other way. And I liken this to what Michael Eisner, when he was running Disney, used to say about promoting a vision called creativity inside the box instead of creativity outside the box. Because creativity inside the box is about framing some kind of financial limitations and giving unfettered opportunity to the designers to find ways to live within the budget but do whatever they wanted to do anyway. And that was the new policy that he applied to rein in the cost of movie production with George Lucas and Steven Spielberg. And that kind of thing is happening in the state local government all over. So in the state of Michigan, there's something called the MyCloud. They built their own cloud. So the state of Michigan, they have a central IT organization that sells infrastructure like Amazon, and they sell storage and applications access to the agencies so that they can develop new applications in infrastructure from the state. So the state is selling cloud services to the state. And it's an incredible model because while they wanted to do business with Amazon, and they told me, we worked together on the Cloud Commission, they couldn't because Amazon was too expensive. It was twice as expensive for what their budget allowed. So they built their own. When I heard that, I called Amazon and I said, do you know what Michigan's doing? They built a service like yours. If they ever get the opportunity to sell it commercially outside the border of Michigan to non-governmental agencies, you guys are in trouble. And actually, Amazon is working with the state of Michigan today to come up with an even more expanded model. But that's the kind of thing that's possible and that's happening. And Michigan is a real thought leader in that regard. They're not the only one. This is happening in many states. But they're also now looking to each other for ways that they can share infrastructure or take ownership of delivering one application for many states to make it more cost-effective. So, for example, one state in the Midwest might own delivering all the email systems for a Midwest consortium. And another state might own offering all the web servers for access to information, public information for the citizens. And this is the kind of new business model innovation that is resulting from the IT innovation. It's really quite extraordinary. I had Michigan. I spoke to the Republic of Kazakhstan, who is building a national cloud strategy. I met with them last year and have been working with them since on what they can do in the cloud for their own government. They have the challenge of supporting a very large landmass with only 3 major cities, a lot of people who are very remote. They don't have good IT infrastructure. They don't have good telecom throughout the whole country, but they want to leverage cloud computing and mobile to reach people who are remote in particular. That's one way to do it. And we have had an opportunity to connect them with Michigan. I spoke to them about what Michigan is doing, what Illinois is doing, what the state of Oregon is doing as a way to help teach them. And so there's an opportunity for what's happening in the United States to be used and influence things that are happening in other parts of the world. Now, the Illini Cloud in the state of Illinois is another one that's absolutely fascinating. This came out of one school district, K through 12, in Bloomington, Illinois. They didn't have enough resources, they didn't have enough people, they didn't have enough budget. They had no idea how they were going to run the systems that operate the school district. So they built the UNE Cloud, and they started selling services to the other school districts. And the other school districts couldn't afford anything either. But when they all worked together like that and they shared the infrastructure, now they can get access to better software, more sophisticated functionality and applications that they had before than they have had before, and have it cost less, and have a central support team at the original school district help them be successful. This was so compelling in the state and caught so much attention that the governor took over. and they're working with the Gates Foundation. And this is for K through 12 education. And it's not about delivering specifics in terms of delivering course content for teaching. It's more about running the operation of the school district. That's what they're doing. But it opens the door to creating opportunities to innovate how you deliver everything else in the school district. And that's another great example of what's happening in government and in education. In another example, this whole idea of data, everybody's talking about big data. One of the key questions is, what is big data? Big data is big. I'll talk a little bit about that later. How big is big data? But there are several experiments going on with the release of government-held public data that's really our asset as a taxpayer that we should have access to, and integrating the data and making it available to communities and developers and journalists and researchers to do something with it just to see what happens. The release of the GPS data years ago, when it was it's owned and managed by the government, but making GPS data commercially available has resulted in a number I saw in a report was $90 billion of economic value, simply by releasing the data and making it available to the business community to do something commercial with it, make money off it. I mean, so there's this big move on in the government in the United States and in other places to make the public data available and find creative ways to help serve the citizens better with information, but to allow the citizens to use the data to actually drive economic value. And in Illinois, again, they have Chicago, Cook County, the state of Illinois are the first to develop one integrated system for data where they share things like, where's every hospital? Where are all the police departments and the fire departments? Things that are so simple, but that we don't have today. But by consolidating all of that data, now you have the ability to mine the data and look for trends and do analytics. And that's one of the big things about making open data available. And then the last example I want to talk about regarding at the state-local level is this was one of, I think, the finest examples of cloud computing and how this can change local government. That I worked with these people on the U.S. Cloud Commission, and that was in Larimer County, Colorado. And what they did was they built an application in the cloud, so they didn't have to buy the infrastructure. They just signed on to use somebody else's infrastructure in the cloud. They built a custom application. One IT person, 40% of his time, it took 8 months. And he built an application to integrate case study customer data and case study intake across many social services agencies for food, job assistance, housing, clothing. All of these agencies were completely disconnected and completely uncoordinated. Some families were able to access more than one service, and other families were not eligible. By putting the data together and giving the social workers access to determine who was eligible for what and proactively put together packages of services to deliver them together to the people in need was the greatest innovation that resulted from this, all because they were able to build an affordable application and then run it in the cloud. They're signing up nonprofits. They're signing up all the agencies in Larimer County in conjunction with the county government to do this and access the application and deliver services. It only costs $5,000 to sign up and $40 a month to then use the software after that. And that's the kind of change that can be driven by moving the IT infrastructure to the cloud. From a federal perspective, with regard to open government, transparent government, everybody remember the economic stimulus package from a few years ago? Do you have any idea where that money went? You want to know where that money went? You want to know where the money may have been applied here in Portland? You can find it. It's online, and it's called recovery.gov. And I'm sure the folks who are listening online, too, are wondering about money in their communities. Recovery.gov, there was legislation passed requiring that a website be created after the stimulus package was passed to track the money and make the use of the money visible to everyone. This is the first of the cloud-first applications built by the federal government, and it is a huge success story. Recovery.gov took, and my company was involved in this one too. This was SAP Business Objects software to allow you to look and scan and do analytics on data, combined with Microsoft SharePoint to manage the content, combined with ESRI geospatial maps so that you could click on a map, drill down into the data underneath and see what projects, money, and contractors were hired for what location, and where was that relative to where you live. And the system integrator was Smartronix. And the reason I mention all the vendors is because I think this is one of the most creative things I've ever seen. And I want to make sure that the vendors are identified and get credit for that. And the application was built and hosted in Amazon. 22 days from feasibility study to production. It only took 22 days to get all of this work done and make available to all of us as citizen taxpayers access to where our money was spent in the stimulus package. I personally found out that the reason my street was torn up and new trees planted and a new island put in and the street was widened was paid for by the stimulus package. I had no idea until I started browsing around on recovery.gov just for kicks. And what's interesting about this, too, is that China loves recovery.gov. I had a meeting with somebody, the Vice Director General of the Ministry of Science in China, and he was telling me how much they love this because they did their own economic stimulus package a few years ago, and they couldn't relate where the investments went relative to the jobs. So this site also shows where the financial investment resulted in new job creation. And this is something that this was the very first cloud solution from the cloud first policy for the US federal government. Now, in terms of how cloud can change the way government works with citizens, there are some really, really fascinating stories and real benchmarks here. So the whole idea of government using cloud-based applications to take government to the citizens instead of the reverse is the big trend that's enabled by new technology. There are many, many applications out there, mobile applications, I don't know if you've seen any or used them, that allow you to report potholes, graffiti, crime, other issues that you could report by way of a mobile device to your local government. The city of Boston is one of the benchmarks for the US. And they have an application called Citizen Connect, where you can identify and report problems by way of a mobile application to the government. And the report is then directed to people who can actually make changes. It's tracked, and the results are made public, so you can then evaluate whether or not the government did its job properly. So you as a citizen now have the opportunity to work with the government remotely, proactively, and to hold the government accountable. And so this is something that is a very popular model. The Philippines is doing something like this as well. In emerging nations, they don't have access to the kind of technology we have here. But phones, simple phones, have become a lifeline for emerging nations to use, not just for communication, but for example, early warnings about natural disasters. That's one of the things, using texting. They only have access to simple texting. Remember when that's what we had was texting? Well, now we have smartphones that are bigger and better than our desktops and our laptops. You know, our phones are basically becoming our major computer. And we have so much access to sophisticated functionality. Well, the emerging nations don't. They also don't have land-based internet access either. So what kind of technology can they use to benefit? And using texting is actually quite popular. So that's how emerging nations are using mobile to stay in touch and also work with their politicians. I met somebody from Tanzania recently who was a politician who came from a very small, very poor village that was remote. And he represented his constituents and how, when he couldn't get there in person, he stayed in touch with them by texting. And it was their way of working with him to make sure that he could represent their needs, that they could communicate their needs, and that's how he could look after them. So that's a big one in terms of how technology is changing the way we work together with government, and we can do so in a proactive way as citizens. In terms of crowdsourcing, I think one of the best examples of an interesting public-private partnership that has come out of cloud computing was around the 1940 census data. And that was released, a year ago, April? And there's a startup in Silicon Valley up the road from where I work called Inflection. And they took all of the data from the 1940s census and they digitized it. So you have a lot of digital images of reports and locations of people and census surveys and that kind of thing. They digitized it and they did the work for free for the National Archives. And then what the National Archives did was they used social media applications and they crowdsourced to the states, state by state, for volunteers, all the genealogy enthusiasts, to actually index the data. So they actually identified the data that had been put in the database so you could search on it, and the volunteers did it for free because it was fun. And they reached the volunteers and basically crowdsourced an ad hoc workforce and used the data, used them to finish off making the data available. What Inflection did at that point was they sold off that aspect of their business to Ancestry.com. So what they did and invested in for the government for free resulted in a big revenue generator for them in a bigger strategic plan. The National Archives got the census data archived and made available with the technology industry on time, on budget, for free, and they engaged the citizens using social media applications to partner up and get it done. And I think that is one of the best ways, best stories about how government and citizens can work together on common goals in a way that creates great work and doesn't cost a lot. And that's because of the confluence of cloud, mobile, social, and big data. And these things were not possible before. Well, they are now, and they're happening everywhere. The last thing I want to say on this particular slide is, everybody familiar with the Civic Hackathon, National Civic Hackathon Day that took place June 1 and June 2? So hackathons have been going on for a while. And on June 1st and 2nd, that was a designated weekend. The federal government designated that as the national weekend for hackathons to go on in many cities. So there were something like 80 cities that participated. It was organized by Code for America, Random Hacks of Kindness, which is developers who do stuff for free, and some other corporate sponsors like Intel. And on that weekend, developers got together to work with government to take the open data, the government-owned data, and build applications around it or build prototypes. so that you could see what is possible with the data to begin to build new applications to deliver better government services. And there was a hackathon in Bangor. And what they did in Bangor was they developed applications for tracking snowplows. So they could identify where the need was, where the plows were, and then fix the difference. So that was one thing that came out of the hackathon from Bangor. And this is a way for citizens and government to, again, get together and work together to solve problems together. Because when I talk to public sector people, agency people, what they tell me is that they're really under the gun because citizens aren't willing to wait anymore. They're just going to solve the problem themselves because there are so many tech-savvy people now, especially the young people. There are so many tech-savvy people that citizens are finding a way, and they're either going to work with government or they're going to work around them. So, and that's what's happening with hackathons. Hackathons are happening all over the world, by the way. There was a hackathon in New Zealand recently. There was one in Estonia. It's astonishing. This is not just a U.S. thing, but the U.S. is the furthest along, has the most benchmarks, and frankly is the leader. And what we're doing here is leading the rest of the world. It's astonishing what's happening. It's really exciting. And I live in Palo Alto, California, where people, young people, young developers are coming from all over the world just to be in Silicon Valley, to work in a startup, to launch a startup, to get access to Stanford, to get access to venture capital. Or the young people are all coming in to work for Facebook because it's hip. So some of the other things regarding how cloud is impacting jobs and business. There is an initiative called Startup America, or Startup Weekend, that was launched by Steve Case. If you remember him, he was the founder of AOL. And he works with Reed Hastings, who's the CEO of Netflix, Reid Hoffman, who is the CEO and entrepreneur who founded LinkedIn, and several other CEOs. And what they're doing, they were working with the Obama administration to develop volunteer groups of mentoring communities to support startups, Silicon Valley-like startups, everywhere. So there are people launching startups, and they're not just software-driven startups. In Connecticut, for example, there was a group of parents who got together and decided they didn't think their school system was doing a good job with substitute teachers. So they had an application built to identify good teachers, substitute teachers, so that they could influence the school district. And they were trying to influence the school and get the school district to actually change the process and bring in better teachers for their children. I mean, there are startups like that that are happening that are just incredible, they're always software enabled, but they're not simply just about building new software. There's a process that somebody starts and then has software built to support it. So Startup America is all about bringing the community together. So developers, attorneys, accountants, marketing people, people with strong business skills to be available to pro bono work together to help advise the young entrepreneurs. Because the entrepreneurship in this country and small business is really the engine of the economy. So this was a way to help spark the economy for small business in particular. They work with the New York Stock Exchange too, and they offer what they call corporate connections. They call it a dating service. And I work to help these folks. I help mentor some of the startup entrepreneurs, and I work with the New York Stock Exchange and the Start America folks. But this dating service is to match large companies like mine with startups that might have new innovation for an interesting business partnership, or maybe they're an acquisition prospect. But they can meet and greet securely online, get to know each other, and decide if they want to have a face-to-face meeting for a business conversation. And that's another opportunity that has come out of being able to use cloud computing to support startups. And startups, in Silicon Valley, venture capitalists love cloud computing because all the software startups, usually they have to buy computers and storage and set up data center facilities somewhere. But now that they can just write their code and develop their applications in the cloud, whether it's Amazon or Rackspace or Microsoft Azure, any of the development clouds out there, they instantly save 10 to 15% on in cost efficiencies for the venture that they're getting from the venture capitalists. So the VCs love the cloud because automatically there's 10 to 15% of their money that's now going towards building the application instead of buying the hardware and the software to do something about it. And it's almost at a point, it is in fact at a point, I talk to VCs. I write on Forbes and I like to interview the VCs and the startups because they're really interesting about what's happening. And one of the things that they do, that they require now that software startups actually build in the cloud, because if you don't, you end up spending more of their money than they're comfortable with. They're all about equity. They're looking for the next big win. So, and Singapore is doing a phenomenal job. Singapore is the benchmark in Asia. The government has taken over in building community places, resource buildings with people, with experts to help the startup community. They would like to become a leader in mobile applications around the world. And everybody in that part of the world defers to Singapore for the incredible work they're doing, because they want to build a new competency for their country so they can create revenue and have their piece of the pie in the IT industry. That's the kind of thing that's happening. I just listed a few on the right. I want to make a quick comment because I've just 10 minutes or so left. But I listed on the right some of the startups that are appearing that you may or may not have heard of. MobileWorks, I want to say something about. This is a socially conscious startup, and it is just incredible. It's in India and in San Francisco. And several people got together and created an application to actually broker work from large Western companies to people in India who needed a second income, people who don't make enough to support their families, and they can actually do web content or some kind of data tasks, something about, maybe loading data to a website or doing, web design or web maintenance, something like that, simple things that Western companies need, that this MobileWorks created an application to assign Western company work to people in India to do either in PC cafes or on low-cost mobile devices. And it is a way to source an ad hoc workforce for IT applications requirements of companies that have large infrastructure to help create work for people who don't have infrastructure. And that kind of model we're seeing in the nonprofits too. So it's an opportunity to use technology to actually deliver work to where the workforce is. And that's something that wasn't possible before either. So there's tremendous creativity going on around the business models that's enabled by cloud computing. Some of these other startups, just briefly, there is a wonderful Croatian startup. I work with their CEO, I mentor their CEO, called Farmeron from Croatia, just farming software. How do you run a farm more efficiently? How do you track the health of your animals? It was incredible. Some of these are infrastructure startups. All the infrastructure is changing. We've got lots of very prominent serial entrepreneurs in Silicon Valley that are reinventing everything. It's really exciting. From a research perspective, I think the human genome is probably the most. It's unbelievable what's happening with the human genome. Personalized medicine is not that far off. That means everybody at some point will have the ability to have your personal genome, all of your DNA, mapped and understood to help identify and target treatment for you if you have cancer, or to help the people in the drug industry develop better drugs that are more targeted for what works for you genetically. Because, for example, in the case of breast cancer, there isn't one kind, there's 22. And so the ability to do this for everybody in an affordable way is only just a few years off. And actually, my company is actually quite involved in this, working with Stanford and working with several hospitals in Germany about this. And this is huge, and this is going to change medicine everywhere. One of the things about the human genome is that we have the ability to make the data available. The data is mastered and managed by the National Institutes of Health. It's shared in Europe and it's shared in Japan to make it available to the rest of the world, to the 2.7 million biomedical researchers around the world. And by putting data, a copy of the healthy tissue data that's been mapped, to use it as a standard in a project called the 1,000 Genomes Project. Some of the genome data has been made available for free in Amazon for biomedical researchers to use and map to the research they're doing. And the opportunity that was created here was that if you're a small independent individual biomedical researcher, you can afford to access the data, the human genome data for your research, and only do so in a way to get the data that you need for your particular work, whether it's around diabetes or heart disease or cancer, some kind of cancer or Alzheimer's. You only have to access the data you need, and you no longer have to have a massive data center supporting and using all of the data and storing it and working with it, housing it. You don't have to pay for that anymore because it's all in the cloud. And so this has the ability to facilitate global research in the medical space in ways that were not possible before. Everything's becoming more cost efficient. By the way, I had seen a study where Dr. Francis Collins, who led the team that mapped the genome 13 years ago and today runs the National Institutes of Health, he references an economic study that said that the mapping of the genome and the availability of the data in the first 10 years from when the data was mapped to up until about 2010 created an economic value in the startups alone. Startups, helping drug companies, created an economic value of $729 billion. So the big killer app for the cloud is big data. And big data is not just any data. The genome is 26 terabytes of data across all the databases. One file of DNA sequencing data is 20 to 300 gigabytes each, or 5 to 50 times the size of a high-def DVD. Just so you have an idea about how big these data files are. It's really hard to sort of identify and characterize what is big data versus regular data. It's just really huge in volume. And the human genome, I work with a lot of technical people in the community, and I went around asking the question, who's got the biggest data? I figured it was the genome because they're known to have the huge data sets. And they said, oh no, it's not us, we're only 1/4. It's the guys at CERN. So the astrophysics guys are the guys with the really big data. And they've had big data problems for years, but they just didn't call it big data. But that's sort of the fancy buzzword today. But so the physics research community, they're the guys with the really big data. And CERN is it's the particle accelerator in Geneva. And the data they work with is 4 times the size of the genome. And that's only the data they save. The other 98% of the data they don't save because they don't have space for it. That's big data. But they too are moving to the cloud. They've built a hybrid cloud, which is the cloud they use in Geneva that's going to connect and bump over to use capacity in a new cloud that they're building in Budapest. And that's a hybrid cloud. And that's the way data is going to be, really big data sets are going to be handled in future with processing and storage in one cloud, connecting over to another cloud where they have more electricity because they ran out of electricity in Geneva, so they had to go to Budapest to just put more servers in to get more electricity. Electricity is a very big issue for data centers in the cloud. But that is the aspirational goal of how the National Institute of Standards defined what's called a hybrid cloud. And that's one cloud talking to another. And that's where we're headed in the future for some of the big science applications. In another 2 weeks, I'm headed to Washington to attend a meeting at the National Institute of Standards to talk about this and find out what's happening. One other thing I would like to mention here that I think is really, really interesting is the vision for Ford Motor Company. Ford, electric vehicles are growing in adoption. But having the ability to design using electric vehicles and using other sensor technology, which generates what's called machine data. You know, a device creates data that has to get used and processed and accessed somehow. The ability to use the electric vehicles in what's called a smart transportation system, where you have the car actually somehow connected and communicating with all of the nodes of transportation that you use to get from point A to point B. So that might be the car to get to the train station, to get to the city, to get to the sidewalk, to get to the subway, to get to the office, the front office, front door of the office, all of those nodes of transportation. How can you connect those in a way that creates efficiency in travel and transportation to avoid global gridlock? And that's the vision of William Ford, the chairman of Ford Motor Company. And he would like Ford to become not an automotive company, but an automotive technology company. And there are a lot of conversations between the government and Ford and business in general about how they can work together to develop a technology competence to make this their particular slice of the technology opportunity. And one of the reasons for that is because for every job that's created in the automotive industry, 7 more are created in all of the other companies that support it, the parts companies, the integration companies, support companies, whatever. So people don't realize that the automotive industry actually has a huge potential to have one new job create a whole ripple effect that's really big. And so these are exciting conversations that are going on between business and government around new ways of partnering together to solve problems for the community. And that's how cloud will be the engine for big data. You need the cloud compute model to handle that kind of information and then actually do something with it. Oh, I showed you my slide before my big lead-in. So as we like to say in Silicon Valley, hey, you, get into the cloud. So that, ladies and gentlemen, that is the end of my formal presentation on how the confluence of cloud, mobile, social, and big data will ultimately be bigger than the internet, and it is affecting everything we do, everything we touch, everything we use, everyone we talk to, here and all over the world. And I'd love to take any questions from the audience, and we'll take some questions from the online folks too, and happy to hear from you if there's anything else that you would like to know. Thank you.
Before we begin the Q&A, Anouar, the director, wanted to show a couple of photos. So, Dave, you want to switch it over to my laptop? So, Anouar's in the clouds, and he's actually watching the presentation. I was unable to Skype with him, but he was able to watch it, so that is pretty crazy. Anyway.
You know, when Anouar and I talked in New York City, and we were talking about Dropbox and just in general, and then he said, "Well, I want to watch from the cloud. I want to introduce you from the cloud." I thought, boy, he's really a thought leader here, very creative. I think we're going to steal him into Silicon Valley. So if you don't see him around in the next few months, that'll be where he is.
If you have a question, just raise your hand. And
I'm just curious. We have Internet 1, and we have Internet 2, and we have cloud, and we have hypercloud. What follows hypercloud?
What do you mean by hypercloud?
What you said when a cloud talks to a cloud.
Oh, hybrid.
Hybrid.
Hybrid. Yeah.
Hybrid. What follows that?
Yeah. So cloud computing as a compute model was made possible by the internet. Okay, right? So the internet is the backbone. It's the network backbone to connect infrastructure everywhere. And there is a vision for what's called intercloud, which would be a large global ecosystem of clouds connected to each other. And the scientific community is working together to figure out what that could look like. And one of the issues in adoption today, which is typical in the tech industry, everything cycles, where you have proprietary technology that leads with great innovation, and then as the market and adoption mature, you have the evolution of standards and the adoption of open standards, for example, which are developed by groups that do some work for free, and then there's some commercial work built on top. Is that there's a lot of discussion around the use of open standards to develop this ecosystem of global clouds that are connected. And one of the issues, the two issues that most impact the adoption of cloud computing today are things that you probably know from the news, which are security and data privacy. Right, so there are some things that are obvious that make a good fit for cloud computing, and other things that people are not comfortable running in a cloud environment. So you need to figure out where you want to run what kind of systems, and then what should be connected to what. But the expectation and the aspirational goal of hybrid cloud on the part of the National Institute of Standards was to have an ecosystem of clouds connected to each other, with some data processing done in one cloud passed over to another cloud for additional data processing, because the data sets are so big that couldn't operate in only one. And the person who talked about this and talked about how this was the incubator for some really big changes coming that we're only seeing the very beginning of, the tip of the iceberg, was Vinton Cerf. I spoke with him at the National Institute of Standards a year ago about this. Well, actually, it was last November, and it's almost a year ago. And he addressed the whole scientific community that was present at the meeting and talked about what's possible with this. He's the co-father of the internet. And the thing he encouraged the technical community in the room was to try new things and really push the envelope, because the opportunities here are just enormous. So I don't think we really know where we're going, but it sure is exciting.
Hi, I was fast.
Go ahead, I'm sorry.
Oh, yeah. The questions I have is, you'd mentioned that in CERN they didn't have enough power. And is that going to be a location problem for some of these companies? I know Google and I believe Amazon have building huge farms in, I think, somewhere in the eastern seaboard.
Oregon.
They want for the power to supply them.
Right.
And then the second question I have is, the highway for us to get on it going to be big enough, or is there going to be another development to increase the speed?
Yeah, so I think Google, Amazon, Facebook now just recently have located and built large data centers in Oregon, where the cost of power is a lot less expensive, because the data centers are so big that the cost of electricity is a factor. And it's it's very fundamental, but you don't really think about that as a factor in how you build a data center. But it is, because the scale of these data centers is so big. So yes, location will come into it. And some of the technical people that I know, for example, Randy Bias, who was involved in building the Google Cloud, Chris Kemp, who is originally from NASA but now has his own startup in Silicon Valley to build private clouds. The thing that they identify as one of the greatest problems is server capacity and the cost of power. And there are low power servers, I think, a chipset that came out of the UK called ARM chips that are going to replace what is used in servers today. And so that's the first step towards getting greater efficiency and horsepower out of the boxes with a smaller use of electricity. So yes, there will be reinvention. Everything's being reinvented. So in terms of speed, I don't know what's happening in the network space But I know that in the data load space, there are startups in Silicon Valley, one of which was purchased recently by the large storage provider EMC, and then there's another startup called Pure Storage. And they're taking flash memory, which is the kind of memory that's in your camera, and it's in your smartphone, and building big arrays of flash memory to support enterprise servers and enterprise applications like for the cloud, because the ability to move the data is a lot faster. And so the traditional way of connecting storage devices to servers isn't fast enough to support the cloud, not when the data is so big, not when you've got 1 billion teenagers loading a photo on Facebook at the same time, that kind of thing. So that's changing too. I can't really speak to what's happening on the network side, with Cisco routers and that kind of thing. I don't know. But I do know that everything about infrastructure that I've seen in Silicon Valley is changing. This is changing everything because it has to. Oh, the woman in the pink, you had a? Okay.
Thank you. I went from being totally ignorant to a little bit. But I'm just curious, how large are these facilities, these storage, and how many throughout the world do you envision once this gets going full bore?
I don't really know how many, how big they are. How many servers they have, how much infrastructure they actually house. Some of that information's not public because they don't want it to be. What I have heard is, for example, the data centers in Oregon, for example, there's hardly any people that work inside, that they're staffed by very small teams because they're so, like Amazon is so heavily automated, and they're very high security with multiple, levels of authentication required, identity management to get in and actually be inside the building, but that I have no idea in terms of size. The adoption of the cloud computing model is happening, certainly in the United States. Most major providers are doing something. The software providers, a lot of the software is being delivered now as a service where you pay a fee and you access software as a subscription and you get it online, or you don't pay anything because it's paid for. The internet applications are usually paid for by advertising, so you don't pay anything for email or for, Twitter and that kind of thing. So most of the software is moving to a software as a service model. This large system integrators and the hosters, the vendors that were offering some kind of IT hosting, like Hewlett-Packard, IBM Global Services, Accenture, Deloitte, the big federal hosters like CSC, Verizon is very big in this space. They're all switching to a cloud compute model because the cost of providing infrastructure to support somebody else's applications is so much less. So everybody is moving to the compute model. So in future, it's expected that, this will be the de facto compute model for infrastructure, replacing just about everything. However, I did speak with the chief technology officer from NOAA, which is the federal agency of which the National Weather Service is a part. And he said that from their perspective, they work with the big supercomputing centers, which use a different kind of a compute model, and that will remain in place. They don't expect the cloud to replace that because the kind of processing they do and their weather simulation algorithms, for example, are so big and so compute intensive that they don't think that the cloud would handle that. But I don't know. We'll see.
We are both biomedical scientists, and we use big data sets, DNA sequences that you've talked about. And I know it's going to get bigger and bigger because it's not just DNA, there's everything else that takes place in the nucleus. But the problem that I see and that we are experiencing is getting good bioinformatics, people to work with us. And I see that the limitation that's going to be coming from what you described, so we really need a large cadre of people who, we could contact and say, can you solve this bioinformatic problem for us, and have it done in the way that you're describing. problems being solved. I think that those kind of people, as electronics of the system.
Yeah, and you know, that's an interesting question. It's absolutely true. And in 2 weeks will be the 2013 launch of the U.S. federal big data initiatives. And that was last year, the Obama administration allocated $200 million to go to the agencies to identify and innovate big data technologies for things like the human genome. NIH is actively involved, the National Science Foundation is very much involved. And this will be the second year of identifying ways to work with the technology industry, public-private partnership, that kind of thing, to come up with better ways to apply technology to solve certain problems. I spoke with someone recently from the National Science Foundation who's involved in this, who described exactly the problem that you said, is that they're trying to figure out how to change education in this country to support the need for what's called data scientists in future, because some of the reports that are coming out for the changes from the technology are going to require that we have a different skill set and we have different kinds of IT people in very big numbers in the near future to support things like bioinformatics. So that's under discussion among the folks who determine science policy and science education policy for the country. And the other thing that I would mention is the folks who manage the data from the human genome. I work with those folks at NCBI, the division of the NIH that manages the data, and they're part of the National Library of Medicine. And they are in the process of trying to figure out how they can architect infrastructure that will allow them to manage the data in a new way, in a more cost-efficient way, because the growth in the data is just getting bigger and bigger. They have to find ways, more cost-efficient ways to support all of the infrastructure to manage that. And in addition, they're working with startups. There's a startup in Silicon Valley who is, I wrote about it on Forbes. I can give you the link afterwards if you want to. It's called DNA Nexus, and they have a wonderful vision. They're working with the Human Genome Research Institute on, they have developed applications that for creating easy access to researchers for visualization tools for DNA sequencing data. And what they want to offer is kind of like an iTunes store of tools that you can download and use. And so you would have access in a central place, and the 1,000 Genomes Project includes that as part of its vision. And the Cancer Genome Atlas, which is going to be all the tumor data, the tumor genomics data will go into that. They're in the process of discussing and architecting that right now. They too want something where they can create access to visualization tools and infrastructure for all the researchers. And the one piece that's missing is the consultants who can help with the bioinformatics. And that's the piece that I haven't heard anything specific about how to solve, other than that the NSF is aware. Oh, there's also something called the Open Data Alliance that was launched in Silicon Valley. Recently, the Open Education Alliance with Google, Cloudera, who's a big data startup, they work with Hadoop. They sell enterprise tools for Hadoop. The Khan Academy, Autodesk, a bunch, they're working, and Udacity, who did the big MOOC test just recently. They are the two guys from Stanford and the venture capitalists that offered a free artificial intelligence class and expected 3,000 or 4,000 students and got 160,000 enrollees in 90 countries. They're involved, and they're the ones who sponsored this Open Education Alliance. So part of what they're doing is trying to work with the government to figure out what does the technology industry need in the education curriculum in future to support the use of big data. And genomics will be part of that, but won't be all of it. So there are initiatives like that that are happening, floating out, that are sort of bubbling up But I don't know of anything that's more really big and substantive beyond that right now.
I'm hearing an unbridled optimism that with cloud computing, as the price point gets lower, all sorts of and the speed gets greater and the availability gets greater, all sorts of things become possible. But what I'm not hearing is the cross-disciplinary discussion about the real social problems that our society has and how this technology relates to them. The distribution of wealth and power, the difficulty we have in forging democratic institutions in which people really feel heard, education for creativity, dealing with social integration when people get distracted into their virtual worlds. What kind of dialogue do you see happening that really looks at how we begin to redirect our technologies even as we advance them?
I think that's a really good question. You know, we were talking about this earlier, and I've had this conversation. I was recently at another event with China, and this question also came up. And I think one of the things that always happens with the technology industry, I've been in Silicon Valley. I've been in the industry for more than 25 years. I've lived in Silicon Valley for 17. And one of the things that always happens with technology is that people have the opportunity to be creative. They're going to just do anything because they can. And some of the issues that come up with that, for example, data privacy, and the fact that there's a lot of information about you that's online that you may not want out there, but you put it out there and you may not even know how. And you know, how do you protect against that? How do you limit that? You know, the consequences sometimes of the social consequences of technology innovation are usually identified after something's already out there. So how do you change the process? How do you rein that in? There's a lot of discussion in Silicon Valley right now about certainly education. You know, how do we change the way people are educated so that they are have the skills to be operating in this environment? There is a lot of pressure on Washington. I work with the high-tech lobby. The primary lobby is Tech America, Trade Association. Most of the tech companies work through Tech America. Many tech companies have their own lobbyists in Washington, trying to educate the policymakers to address some of the legislative issues that lag way far behind technology. You know, often technology legislation is 10 years behind. It gets reviewed every 10 years. And things are changing so fast that some of the policies, like around email privacy, for example, are so far behind the way we do things today that they're just not relevant anymore. And that's a problem that's very well known. I don't know that there is a really good, fast solution for it, but there is a high-tech caucus in Washington that is supposed to look at accelerating discussion around the high-tech policy issues around data privacy and that kind of thing. They're chaired by somebody from Texas and somebody from California. The creativity discussion is a fascinating one because in Silicon Valley, there is, the pace is so fast now for new innovation that everybody's looking for the competitive edge. And there's a lot of discussion around how do we facilitate more creativity and productivity in an environment that is so stressful where people work 12, 16, 20 hours a day, and yet they're expected to perform because the competition is so great between American companies, but now there's competition coming from other parts of the world. Estonia is becoming quite the application developer, they have a young CIO. They have a young CIO for their country who is very social media savvy. He leads the EU in the member states. He's the leading CIO for the member states in the EU Cloud Commission about how to drive cloud opportunities between the member states. So we're getting competition from everywhere. And the conversation in Silicon Valley is, what do we need to do with the education curriculum, and what do we do for the people so that we can facilitate this kind of productivity and creativity going forward? There's a very interesting new group that I'm just getting involved in now called Wisdom 2.0. And it was facilitated by someone who's a journalist, and he has very close ties to John Kabat-Zinn, who developed process for mindfulness meditation and has initiated doing research around. And so some of the activity that Wisdom 2.0 is trying to put forth is some of what Wisdom 2.0 is gathering people from the technology industry to get together to learn mindfulness meditation and other techniques for stress management. That would be ways of being able to get more quality of life out of living the way you do. I mean, the folks in the internet industry they work probably the longest hours of anybody. They have to. And it's just the way the industry works. But that's one area where there's a recognition that the way we work is potentially going to have a negative impact on what we can produce in terms of creativity and innovation. And the other thing I'll just mention, because we talked about this earlier, that I think is really fantastic, is that Stanford has a multidisciplinary curriculum where I think it's driven by the engineering school, so it's the computer engineering. They work in conjunction with the business school, and they have somebody there's actually someone from the medical school who's involved. She's a psychiatrist and a sculptress, a woman I know who's just incredible. And drama, theater, performing arts, music, all of these people in a cross-disciplinary curriculum teach creativity, how to foster becoming more creative, and how to bring all the disciplines together to help develop better software. It's fascinating. So those are some of the things that I'm aware of that are happening, and and certainly it's probably not enough. Sure.
Coming very close to home. UNE is home for, I think, the only medical school in Maine, and now a pharmacy. Medical records seem like a godsend. Wonderful, and each provider that I see knows what's going on, and it's hard to solve that. It was a very doctors are getting to look more at their computer screens than at their patients.
Yeah.
And they're trying to physically redesign things so that doctors connect to patients even as they have access to the data and all the computing power behind it. Rather than leaving this discussion to the technologists, why aren't institutions like UNE in their medical school questions of how do we integrate technology in a way more humane challenge for the technologists, challenge for those who use it.
Yeah. Well, I think as consumers, we have to push back on what we want, what we demand. Something that's happening at Stanford Medical School is the use of horses with medical students, because working with horses because of herd behavior have the ability to communicate immediately when you don't approach them properly, when you create threat, when they are comfortable and feel safe with you. And so working with what's called equine-assisted awareness building and leadership and education, as horses are used with handicapped children, they're being used for students at Stanford Medical School also to learn about how to engage in a more human way with the patients, because so much of that is being lost by the technology and by the time that gets spent with just very high workloads that create a stressful environment that don't allow a very humanistic person to be particularly human with the patient. So, do we have anybody online that had questions, or?
I don't
Are you
believe
okay?
so. But we'll
Okay.
we'll end here. Thank you very much, Jacqueline. We appreciate it.
Thank you very much for your time.